In this video, we'll be learning how to solve and graph compound inequalities. So number one, you'll see there are two inequality signs in the statement we're given. So if we take a look, you see both inequality signs. And so when you see something like this, the first thing you want to do is split it apart into its own two inequalities. So I'm going to first do that by taking and rewriting this statement. So negative 18 is less than x plus 6. And I'm going to write a second statement using 6 plus x is less than or equal to 24. So notice how the middle part, what's in between the inequality signs, this gets used in both of those statements. But now that I've split it apart, now I just have two separate inequalities to solve. So for this first one, I need to subtract 6 on both sides. That doesn't change the inequality sign, so bring down x and then minus 24. I'm going to flip that around, so it's x is greater than negative 24. And there's one of them. And then the second inequality, subtract 6 as well. But this time, I have x left over less than or equal to, and then 18. And then that's my second inequality. Now, what I didn't mention was what connecting word do we need for these two inequalities? And that's one of the most important things for solving compound inequalities. Whenever your inequality, your compound inequality is written like number one, the way it's written, it's always going to be an and. All right, so that means when we shade, we're going to be looking for the overlap, if you remember that from last class period. So I'm going to graph the two inequalities separately on their own number line. So my two key points are negative 24. I'm going to set up all three of those number lines first, and positive 18 are the two boundary points. That first inequality is x is greater than negative 24, so open circle to the right. The second inequality is x is less than or equal to 18 rather. So closed circle and to the left, less than. So now the key part here is the and. So this final or third number line is going to show what we mean by and. And means overlap. So where do these two shaded regions overlap? Well, they start overlapping from negative 24 all the way to 18. So I'm going to use the same boundary points. So negative 24 is open circle, 18 is a closed circle, and then I'm going to shade in between. All right, so the key word there I want to connect is overlap. All right, so the red and the blue overlap in between. Number two is going to be very similar. Notice again how the inequality is written together. And I'm going to first rewrite that by just splitting that into two separate inequalities. Again, when I do that, notice, this is the key part here. Notice that the in-between, right, what's in the middle is used in both of those inequalities that I just rewrote. So now I'm going to solve those. The solving is going to look kind of similar for both of them. So I have v and then negative 20. And then I'm going to flip that around. So v is greater than or equal to negative 20. And then for the second one, v is less than negative 8. Once again, because this inequality is written together as one inequality, we're talking about in between. That's the key word that we want to use is and. All right, so it has to be this and this. So when I graph those two inequalities, once again, I'm going to set up my graphs. I'm going to use, so negative 20. Negative 20 is my first boundary, negative 8 is my second boundary, and I just like to set up all three number lines right off the bat. When I graph these, I have v is greater than or equal to, so filled in circle to the right. I have v is less than, so open circle to the left. And then once again, it's and. So to represent and, I'm showing all of the overlap. So they overlap in the middle, in between. So closed circle on 20, open circle on -8, and I shade in between. All right, once again, you'll notice starting at -20 is where they overlap. If you were to kind of squish these two graphs together, that's where they would overlap. Okay. Let's take a look at number 3 and 4. So number 3, you'll notice that the two inequalities are already split apart, and you'll see that keyword and. So that just means we don't have to take that first step and split those into two separate inequalities. So we're going to solve each of these. So first one, we get 2x is less than or equal to -10. Divided by 2, we get x is less than or equal to -5. We don't need to flip the inequality sign around. We did not divide or multiply by a negative. The second one, subtract 9. Don't forget the -3x is less than -18. And this time we are going to divide by a negative. So I get x is greater than 6. Once again, this is an and, but let's go ahead and set up our inequality or our number lines to begin with. So we have our key values, our boundary points are -5 and 6. Oops, there we go. And so now we can graph each inequality sign or each inequality separately. So closed circle at -5 and to the left. For x is greater than 6, that's open circle, and greater than is to the right. And if you notice for this one, they don't overlap. So for the and, my final graph, there is no overlap. And that's a key, right? If there's no overlap, that means there's no number that would make both of those true at the same time. So there is no overlap, which means I leave the graph blank. So let's go ahead and finish with number 4. I'm going to solve. Again, notice that the keyword is and. We're solving. I'm going to add 1 to both sides for the first inequality. I get 7r is less than or equal to -49. Divide by 7, and I get r is less than -7, less than or equal to. Again, the inequality sign does not switch. I did not divide by a negative. For the second inequality, add 1 to both sides. I get 10r is less than or equal to 50. Divided by 10, and the inequality sign does not switch. So setting up my boundaries, -7, and 5. Sorry if these bottom number lines look a little weird. It's kind of hard with this program I'm using. Let's graph these quick. And we have at -7, it's filled in and to the left. At +5, it's also filled in and also to the left. And so this one's going to work out a little differently. The overlap starts at -7. Notice how both shade areas go to the left, but they don't start overlapping until -7. So on my final graph, I'm going to include the boundary point at -7, so filled in, and then anything to the left. So notice how there's no boundary point at +5. It is not a part of my final answer. So again, this is still an and, so I'm still looking for the overlap, but the overlap only starts up here at -7 and to the left.